Good morning, children. Today again we are continuing the chapter lines and angles. Now you came to know that the geometry chapter, how it is little bit difficult only. So listen carefully. So what is transversal? A line which intersects two or more lines at distinct points is called a transversal. Already we have learned all this in the lower classes. Just recall the properties only. What is meant by transversal? So a line which intersects two or more lines at distinct points. So that means L is a transversal here. L cut M and at distinct points. If I mark here X, at X and at Y. So at X and Y, L cut M and N. So L is called the transversal. So L is the line which intersects M and N at X and Y. So L is called a transversal. Now while cutting the line, you can see that 8 types of the angles are formed. We already marked in the diagram. So the names you have already familiar with you. Corresponding angles, alternate interior angles, alternate exterior angles, interior angles on the same side of the transversal. So first we will learn which are the interior and which are the exterior angles. Which are the exterior angle means outside the line. 1, 2, 7, 8. 1, 2, 7, 8 are marked. They are exterior angles. Where 3, 4, 5, 6 are called interior angles. So all angles only here. 1, 2, 7, 8 above the line and below the line, it is outside, so they are called exterior angles. And 3, 4, 5, 6 they are called as a interior angles. And now this, what are the name of the other angles we have studied? Corresponding angles. So corresponding place only, that one, that is why these angles are called corresponding angles. So first I'll consider the one is the angle and it is above the line and left side of the line, right? It is above the line and left side of the line. In the same place with the second line, the angle is 5 there. So angle 1 and angle 5 are the first pair. So how we are deciding corresponding means it is 1 is above the line. Similarly 5 is also above the line. It is with first line, it is with the second line. Now which side it is? Left side of the transversal. So 1 and 5 are the corresponding angles. Now I'll consider for angle 2. Angle 2 is above the first line and right side of the transversal. Similarly, angle 6 is with the second line and right side of the transversal. So angle 2 and angle 6 are the second pair. Similarly, angle 3 if we consider means, angle 3 means below the first line and right side. So below the second line it is angle 7. Similarly, 4 and 8, the last pair. So 4 pair of corresponding angles we got. In place of 1, angle 5 will come with the second line. In place of 2, angle 6 will come in the second line. Angle 3 is there for the first line. 7 will come in the place of that with the second line. 4 is the first line with the first line, and the same place you can see angle 8 with the second line. Now alternate interior angle. First it should be interior angle. Interior angle how many are there? 3, 4, 5, 6 only. Now alternate, not on the same side. So if I am taking 3, the next side it is coming 5. If I am taking 4, it is coming as 6. So alternate interior angle. Already we know that 3, 4, 5, 6 are the interior angle, but it should be alternate. One from the left side means other from the right side. So angle 3 and angle 5. And which is the next pair? Angle 4 and angle 6. Now alternate exterior angles. We have to write that alternate exterior angle. So which are the exterior angle? 1, 2, 7, 8. So 1 we are taking from this side, then the exterior angle is from that side, it is 7 only. So angle 1 and angle 7. Now next pair is angle 2 and angle 8. Now the last point, interior angle on the same side of the transversal. So already we know that interior angle 3, 4, 5, 6 only, but it should be the same side. So angle 3 if we are taken the same side, it is angle 6. see 3 and 6 are on the same side of the transversal. Similarly, angle 4 and angle 5 are the same side of the transversal. Just recalling the names of the angles what we have studied in the lower classes. Interior angles on the same side of the transversal is also known as consecutive interior angles, allied angles, or co-interior angles. Co-interior angles are very familiar word to us. Now other names also you can see, consecutive interior angles or allied angles. So these are the names you should remember. So commonly what we will use, co-interior angles only. Corresponding angles axiom. Converse also axiom, and corresponding angles axiom only. Direct also it is axiom only. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. So this is the first statement, and we know that a parallel line is cut by, two parallel lines are cut by a transversal, corresponding angles are equal. Converse, what is the statement? If a transversal intersects two lines such that a pair of corresponding angle is equal, then the two lines are parallel. So here what we have to study means it is an axiom only, so there is no proof for you, only the statement, and we learned in the lower classes only. This statement you are knowing already, just a recap only. What is this one? This is called as a corresponding angles axiom. So single one, this is itself is called a corresponding angle axiom, and converse it is not coming as a corresponding angle axiom, it is a converse of corresponding angles axiom we will tell. So what is the corresponding angle axiom? If a transversal intersects two parallel lines, the corresponding angles are equal. What is the converse? If the corresponding angles are equal, then the two lines are parallel. With the help of the diagram we can see which are the corresponding angles. Angle 1 means angle 5. So angle 1 equal to angle 5. What is the second pair? Angle 2 is equal to angle 6. Angle 4 is equal to angle 8, and angle 3 is equal to angle 7. Right? So just same place with the second line, 5, 6, 8, 7 are lying. So we have considered one above the line, and also it is with the first line and left side of the transversal. Similarly 5 above the second line and left side of the transversal. Similarly you can see this one. What is the condition now? Previously we have written the pairs, now it is parallel means all these values are equal. That means if it is 30 degree means angle 5 is also 30. If it is 60 degree means angle 5 is also 60 degree. Like that you can tell the remaining angles. Next is theorem. If a transversal intersects two parallel lines, then each pair of alternate interior angle is equal. Since it is a theorem, we have to prove. Last time we have seen that corresponding angles is an axiom only. Axiom is not required any proof. Now the second part I have written that theorem 6.2. The first theorem we already written yesterday, that is vertically opposite angles are equal. Now the second theorem from this chapter, if a transversal intersects two parallel lines, then each pair of alternate interior angle is equal. You can tell me that we know this one, but we have to prove like a theorem. That means a statement to be written, reason should be written, then only we can. So first only I told that you should identify what is given in the question and what is to be proved. So read the question means if a transversal intersects two parallel lines, that is the given part. That means a transversal is L, parallel line is M and M. So we'll write that M parallel to N. Right? Next, then each pair of alternate interior angles is equal. Which is to be equal, we have to prove angle 3 is equal to angle 5, and one more pair, angle 4 and angle 6 are also equal. These we have to prove. Angle 4 equal to angle 6 and 3 equal to angle 5. Now proof we have to, here proof means we should use two properties only. That is what we have proved the last means corresponding angles as an axiom we can use, and vertically opposite angle criteria we have to use. So for proving this theorem, whatever we have proved, not in the lower classes, here we have proved here, based on that only we can use. So this chapter we have studied vertically opposite angles as a theorem, and also corresponding angles as an axiom we have written. By using this we can write. So proof I have written. Now the first step is that 3 and 5 should come. So 3 and 5 we should correlate the things. So when we are taking angle 1 is a first angle, it is equal to angle 3 by vertically opposite angle, right? Angle 1 and 3 are vertically opposite angles. Now I can write angle 1 and 5 because which criteria now? Corresponding angles, right? So these two criteria we have taken. Now 3 and 5 are both are equal to angle 1 only. Angle 3 and angle 5 are equal to 1 only. This shows that angle 3 is equal to angle 5, which is we have to prove, which is we need to prove only angle 3 and angle 5 we got here, right? So the first what we have written, vertically opposite angle criteria we have used, then corresponding angle criteria we have used. This is a theorem we have proved and this is an axiom for us. So by using these two criteria we got angle 3 equal to angle 5. Now if you understood this step, similarly 4 and 6 you can tell me first. What is angle 4 is equal to and angle 6 is equal to? Angle 4 is equal to which corresponding? Angle 4 is equal to, we have to bring it 6. So angle 4 is equal to angle 2, we can write vertically opposite angles, and which is the corresponding angles for angle 4? Angle 8 is the corresponding angles, right? So in this way, two way we can use angle 4 is equal to angle 2, vertically opposite angle, same criteria. Then angle 2 is equal to angle 6, corresponding angles criteria. Then this shows that angle 4 and angle 6 are equal. So we got this one. Now if somebody want to use as a angle 8 also, we can go for that one. How we can write angle 6 equal to vertically opposite angle criteria I have written. So angle 6 equal to angle 8, vertically opposite angles, right? Now angle 8 is equal to which corresponding angle? Angle 4. So by this what you can write? Angle 6 is equal to angle 4. Anyway you can write either you can use with the 2 or you can use with it angle 8 also. Once again 2 is the comfortable one, so I'll write like that only. So first is vertically opposite criteria we have used, so I'll write here similarly, right? Angle 4 equal to angle 2, vertically opposite angle. Now angle 6 is equal to angle 2, corresponding angles. Now by using this shows that angle 4 and angle 6 are equal. See this one, this is also we required criteria, here also we required. So what is the, we can write hence proved. So both the criteria we have used and we have proved that alternate interior angles are equal. Next theorem, converse of theorem 6.2 only. This proof is not there in the syllabus, so just a statement for you that already you know. If a transversal intersects two lines such that a pair of alternate interior angle is equal, then the two lines are parallel. If a transversal intersects two lines, that means alternate interior angles are equal, then the lines are parallel. That is the theorem statement we have already studied in the lower classes. No proof is required for this. Theorem only again 6.4, that is the fourth theorem. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. So co-interior angles is supplementary, we have to prove. So co-interior angles means what is that? 3 plus 6 equal to 180 degree, 4 plus 5 equal to 180 degree. So again I have to tell that it is a theorem. So we need to write the steps again. So read the statement and you can see that what is the given in the question. If a transversal intersects two parallel lines, so just we can write M parallel to N. So here I'll write M and N and this line is L, right? Now to prove, that is co-interior angles are supplementary, means 3 plus 6 equal to 180 degree we must prove. Similarly 4 plus angle 5 is equal to 180 degree. This concept you already know, so we have written given to prove only, construction not required. The next step is proof. So related to 180 degree, which criteria you have learned? Means the linear pair only we have learned. So can we write angle 2 plus 3 equal to 180 degree? Check that in the figure. Angle 2 plus 3 equal to 180 degree, linear pair, right? So I'll write here linear pair. Now angle 2 can be replaced with one angle, which is that angle 2, because we required 3 plus 6 only, so angle 2 should go from this statement. So how it can be replaced? Angle 2 equal to angle 6, corresponding angles. Right? So using this in this equation, what we can write, if we write 2 in 1, okay, I'll write using 2 in 1. What we'll get? Angle 6 plus angle 3 equal to 180 degree, which is the required one. He proved first part. Now similarly 4 plus 5 equal to 180 degree. So what we should start? Angle 4 plus 5 we should get. So 4 plus 1 I am starting. Angle 1 plus angle 4 equal to 180 degree. Same reason. What is the reason? Linear pair. But 1 equal to which angle? Angle 5. So angle 5 plus angle 4 equal to 180 degree. Here I'll write the reason. Angle 1 equal to angle 5. So again we got here also one more. Sorry, angle 3 plus 6 it should come, na? Angle 3 plus 6, this is the result. Angle 6 plus 3 I have written. So here we got the first step and here we got the second step, right? So angle 6 plus 3 equal to 180 degree we got, and similarly 4 plus 5 equal to 180 degree we got. So what is the statement we got here? Co-interior angles are supplementary. While taking the angle you feel that it is easy. From here 3 and 6 took and 3 replaced like this, like that we feel it is not easy to remember the proof, so practice more. So here also statement, this is also important theorem only. So what is given in the question? Two parallel line. What is to be proved? Co-interior angles are supplementary. So which criteria we have used? Because it is 180 related. So we have used linear pair. 2 plus 3 equal to 180 degree. Now which is the next one? 2 should go from the statement. Instead of 2 we should get a 6. So what is the possibility of getting 6? Corresponding angles. So angle 2 is equal to angle 6. So we got angle 6 plus angle 3 equal to 180 degree. Similarly angle 5 plus angle 4 equal to 180 degree. Next theorem 6.5, converse of the theorem 6.4. There we have proved that the lines are parallel, co-interior angles are supplementary. This time co-interior angles are supplementary, then the lines are parallel. I'll read the statement. If a transversal intersects two lines such that a pair of interior angle on the same side of the transversal is supplementary, then the two lines are parallel. Now this is a proof is not required for the syllabus. So only statement is means realize what is the statement. You have already learned the lower classes. Co-interior angles are supplementary, then the two lines are parallel. With this I am winding up the classes. So listen children, we have learned the first theorem vertically opposite angles. Then we have learned the theorem corresponding angles axiom. As an axiom we have taken. Linear pair also axiom we have learned. Next theorem we have learned about alternate interior angles are equal. Again we have learned the theorem as co-interior angles are supplementary. Both the converse statement is not required the proof for the corresponding CBSE syllabus. So I am winding up the class. Again I am telling geometry portion is difficult. Practice more. Thank you.